Hi everyone. Welcome to this session. My name is Dheeraj Misra, and I'm going to solve one question from semiconductor physics. Okay, this question was asked in GATE 2024. Uh, the similar concept that I have been always discussing, in our electronic devices classes. Whenever I conduct semiconductor devices classes, I always emphasize on energy band diagram. So I'm going to solve this question using energy band diagram concept. And you would be able to see here, if you have a complete understanding of energy band diagram, you can solve this question in 60 seconds. At least 60 seconds will be needed, okay? Because, you know, uh, and you have enough time during the main you can say that during the gate examination, right? 60 second, you can also take 120 second, but not more than that. But your solution should be intuitive enough, right? So I always try to make the solution intuitive. So let's dive to our the question here. So you see, this question was asked, and this kind of concept we always discuss in our classroom. So you can see that this question was directly taken from the classroom, you can say, right? Because concepts cannot be different, right? Concept will be always same. They can frame the question of any kind, right? But your solution should be completely intuitive and it should take very less time, right? So many of you uh, might see this question and might get afraid. Oh my god, how we are going to solve this question? Because this question does not have any sort of formula or kind of thing, right? It is not a numerical answer type question. It is, theoretical question, and some graph is given, some plot is given, electron concentration with respect to x is given here, and x, right? So, shall we move ahead and talk about this? Yeah, let us see how we are going to solve this question. So, I'm going to solve this question using energy band diagram. One of the very important tool that I always tell, you should know. You take any material or devices, you should be able to draw the energy band diagram. So, I'm just going to solve this question using energy band diagram, guys. You see how to draw the energy band diagram for this kind of concentration, right? So you can say that there is you can say one semiconductor bar, okay, and that semiconductor bar is having the free electron concentration profile of this kind, right? And is doped, that semiconductor is nothing but a doped semiconductor, and they also say that that semiconductor is in equilibrium. So by looking at this doping profile, you should say that that semiconductor is not uniformly doped. That semiconductor has been non-uniformly doped, you can say, right? At some point there is a more doping, and at some point there is a less doping, you can say, right? So there is a gradual change of doping, you can say. They are gradually increasing or decreasing the doping here, right? So if you have a look at point A, right? At point A, so they have doped this much, and then they are gradually increasing the doping, and at B the doping is more, number of electrons are more, you can say. Again, once you move from B to C, the doping is decreasing, gradually decreasing, okay? So this profile is given for non-uniform doped semiconductor, right? Okay, if you're moving from A to B, so your doping is increasing gradually, right? If you're moving from B to C, your doping is decreasing. So can we draw the energy band diagram for this? If you are able to draw the energy band diagram for this, you will be able to solve this question very easily and in very less time, okay? And this question is basically MSQ question, right? Multiple select question, okay, where no negative marking is there. So let us go to the question. That free electron concentration profile nx in a doped semiconductor at equilibrium is shown in figure, where the point A, B, C mark three different positions. Which of the following is are true? So this is MSQ question, right? So in the options, if you go through options also, right? So they have talked about electron diffusion current, they have talked about electron drift current, and they have talked about electric field directions, right? And these are the most probable question, right? We always discuss in our classroom. So when you look at the concentration, right here, the concentration profile, okay, you cannot easily talk about the direction of electric field or the direction of you can say the drift current, okay? Drift current will be always because of electric field, And the diffusion current will be always because of natural process. We call it diffusion process. Okay. And diffusion process, I think everybody knows also. Diffusion process is nothing but a natural process. Okay. Charge carrier always transport from high concentration to lower concentration. Okay. That is called the diffusion process. And in why we are saying it is natural, because you can take any example, right? If you take a perfume, okay, somebody has put perfume on their body, right, and enter the room, so the perfume will start spreading, in the entire, you can say, in the room, right? So always, you can say the fragrance of the perfume is going to move from high to low concentration. I believe this is fine. Okay. So solving this question will be very easy when you are able to draw the energy band diagram, right? You can draw the energy band diagram for your understanding. That's it. Okay. They have told in this question the material is in equilibrium. See, despite there is a non-uniform doping, okay, but equilibrium में आपका semiconductor है. Okay, so what is the meaning of that? What is the meaning of that, guys? Let me take this picture. Okay. This picture I'm going to take from here and will paste here. Okay. ये पिक्चर मैंने यहां से ले ली है. ठीक है. Now, I'm just going to say that this concentration profile, okay, is drawn for equilibrium semiconductor. Like semiconductor bar is in equilibrium. Means in terms of energy band diagram, right? When we talk about energy band diagram, if any semiconductor is in equilibrium, we always draw the Fermi level, right? So your Fermi level is always going to be, constant throughout the material. This is a Fermi level. You know what is the meaning of uh, Fermi level being constant? If the Fermi level is constant, okay, if it does not have any sort of slope, it means that there is no current in the semiconductor, right? It means that there is no current in the semiconductor, or you can say that semiconductor is in equilibrium. Fine. Now, you can notice here is that in the energy band diagram, how do we represent that whether the concentration is more or less? How do we determine the electron concentration from the energy band diagram? How do we determine the whole concentration from the energy band diagram? That we must know, right? See, you should have qualitative understanding of energy band diagram. You should have quantitative understanding of energy band diagram. ऐसा नहीं है कि बस you know energy band diagram. And in the interviews, they will ask question. They will give you any material or devices, and they will say, "Can you draw the energy band diagram?" So you have to look first that whether your semiconductor is in equilibrium or not. If it is in equilibrium, your Fermi level will be always constant throughout the material, right? Now let us try to talk about how do we represent that the number of electrons are, you can say whole, but I'm going to talk about number of electrons here because n of x is given. So number of electron is more means what? The gap between band gap, EC and EF, you can say, right? Okay, the gap. Okay, let's say that here the concentration is less. Okay, here the concentration is less, here the concentration is more, here the concentration is less, right? So let's say this is A point and this is going to be B point, you can say, and this is going to be C point, right? Okay. My Fermi level is constant, remember. My Fermi level is constant always, right? These are the 3 points. Okay. Or else you can forget about these points from here. You can put these points on x-axis, right? Let me take that. So you can just say this is, sorry. Sometimes I'm not good at drawing, right? So yeah, bit. So what we can do here is we can say that this is x-axis and this is a point A, this is a B point, this is C point, okay? Now what you can do here is, since at this point, right, at this point, at B point, the concentration is more, means the gap, let's say this is EC. So EC minus EF will be less, the gap will be less, okay? See, as you increase the doping, okay, remember that the gap, okay, the EC minus EF gap will decrease. If the gap is less, it means that is going to be indicating, okay, at that point, okay, the semiconductor is heavily doped, or you can say doping is high, okay? And at a point you can say the doping is like this, the gap is going to be more, right? So you can join then. Okay, this is EC and this is EF. You can look here guys, this is more and this is gonna be less. Okay, it means that what? It means that the doping at a point A is less because the gap is more. EC minus EF gap, this is EF only. And at B point the doping is high because the gap is less. Okay, fine. Now let us talk about B and C. So you see here there is a more doping. Okay, certainly it's fine, this point is gonna be same here, but here again take it, you see like this. Okay, so this is EC and this is going to be EC only, right? Now your balance band will be where? So remember that the EG is gonna be same, right? Okay, EG has to be same. If you want EG has to be same, then what you have to do? You have to draw the EV parallel to EC. You have to draw the EV parallel to EV. Okay, remember these points. ठीक है, आपको parallel में draw करना पड़ेगा. ठीक है, I hope this makes sense. You should be able to draw the energy band diagram, right? I'm just telling you, okay, though you don't need this much time to draw, but yeah, this is EV. It has to be parallel, okay, to EC. Now, by looking at this energy band diagram, okay, by looking at this energy band diagram, what you can say that my semiconductor is in equilibrium because the Fermi level is constant. And if there is a bending in the bands, guys, bending in the band means what? Conduction band and the valence band. If there is a bending in the band, if there is a bending in the band, it means what? There is an electric field. See, we did not apply any sort of electric field from outside world, right? We did not apply any sort of a biasing or a voltage from the outside world, but still there is an electric field, and that electric field will be built-in electric field because of this slope in the band. If there is a slope in the band, that indicates there is an electric field. That is the power of energy band diagram. I always emphasize this in my classroom. Okay. So many people will say that the electronic devices is very difficult subject, but it is not difficult at all. It is our job to make the subject easy, right? It is a job of an educator, an honest educator I'm talking about. Okay. So if there is a slope in the band, I'm talking about energy bands like EC and EV, there is a slope, it means there is an electric field in the material. Now the question is why there will be an electric field? Why we want electric field in the material? Since the material is what? Material is in equilibrium, it means there is no current flowing, okay? And one more problem is there. The material has been doped non-uniformly, right? It is not uniformly doped. So there will be a diffusion process going on, right? The charge carrier will move from high concentration to lower concentration. Charge carrier here is electron, right? So electron will move from high concentration to lower concentration. And you know that the beauty of if the charge carrier moves in the material, there will be a current. There will be a current, right? So what we want is, if we are not applying any sort of you can say voltage or electric field across any device or a material, okay, there should not be any current, right? Why we want any current? Understand, we don't want any current. So that current has to be balanced, right? That current has to be balanced, so that the current must be zero. See, the total current should be zero. Here the diffusion current will be flowing here, but there has to be electric field. Because of that electric field, electron will start drifting away, okay, and there will be a drift current. So the diffusion and the drift current will balance each other, and your semiconductor will be in equilibrium always. ठीक है, ये आप कॉन्सेप्ट समझ जाओ. इक्विलिब्रियम का मीनिंग यहाँ पर क्या है कि आपका जो मटेरियल है दैट इज नॉन यूनिफॉर्मली डोप्ड, certainly there will be diffusion current. Now the question is, how do we determine the electric field direction from the energy band diagram? ठीक है, हम लोग कैसे फाइंड करते हैं डायरेक्शन? वन ऑफ द वेरी इजी वे आई एम गोइंग टू टेल यू, ओके, एंड देयर आर ऑप्शंस आल्सो, राइट? ठीक है, सो लेट मी टेल यू डायरेक्टली स्ट्रेट अवे हाउ टू फाइंड द डायरेक्शन ऑफ electric field from the energy band diagram. If you are able to draw, this energy band diagram, okay, then you can answer that question very easily, right? So what you can do here is you take one Costco ball or a tennis ball, right? Okay, you can take one ball, right? I'm just going to take. Let's say that there is a ball. Okay, this is a ball. Okay, this is a ball, and you can also take here. Okay, this there is a ball. Okay, now you can understand that why I'm taking this ball. Okay, why I'm taking this ball. The ball is being taken just to find the direction of electric field, right? Okay, whether it will be from A to B or B to C or whatever, according to the option. Take. Now you see, guys, the ball is kept, okay, and there is a slope, right? So this ball is going to be, slipping like this. Your ball will move in this direction. Your ball will move in this direction always, okay. And you can treat this ball as an electron only, right? Okay, in this situation. So this ball is there. Always remember, whenever energy band diagram is given, and if you want to find the direction of electric field, what you can do here is you try to put one Costco ball or a tennis ball or a football and see that the football will move in the slope. Okay, here slope is like this. Okay, bending is like this, so that is going to roll down. Okay, and so you know that electric field will be always opposite, okay, of the electron flow, you can say. So there is a ball and your electric field direction will be in this direction, right? Remember, this is the electric field direction and your electric field direction here will be like this, okay, between B to C. I hope finding electric field direction is very simple from the energy band diagram. Okay, this point you have to note down. So let us go to the option D. For X between B to A, right? B to A, right? The electric field is directed from A to B. Is it correct? You see, electric field is directed from A to B. So direction is from A to B. But what is the correct answer? Electric field must be from B to A, right? So this option is wrong. I hope this makes sense to all, right? This is very important to keep in mind. Okay. Electric field direction will be from B to A. Fine. This is okay. Now let us go to option C. For X between B to C, the electric field is directed from B to C. Yes. B to C. Yeah. This is the direction and B to C. Yes. So option C is going to be correct here. No doubt should be there. For any type of question, okay, whenever you have to, whenever you have to find the direction of electric field, try to draw the energy band diagram, put one ball, that ball should roll down, opposite to that ball movement, the electric field direction is going to be, and you don't have to think about anything then, electron, hole, so many things, your life will be very simple. This technique I'm telling you to solve question during pressure of the gate examination, right? We have a lot of pressure in the gate exam, during gate exam, right? We have a lot of competition going on in our mind. That is useless, okay? Your competition is with yourself only, guys, whenever you're going for any sort of exam. Next. So option C will be correct. Now this is MSQ question, right? So you know that more than one option is going to be correct. Now if electric field is from B to C, now option B, let us see option B. For X between B to A, the electron drift current is directed from B to A, right? Okay, electron drift current. See, remember that, yes, let's say electron is flowing from from left to right. Okay, from left to right, so current will always flow in the opposite direction of electron. Remember this, okay, because electron has got negative charge. Okay, so जब आप drift current की बात करेंगे तो you have to take this football as a electron. Remember that. When you are talking about diffusion current, don't take this football as a electron. Please remember, this football or Costco ball, right, or a tennis ball, you can say, is considered to be as electron when we are talking about drift current. Okay, because this football has helped us to find out the direction of electric field, and because of electric field only there will be drift current. Okay, not because of diffusion process. Drift current occurs because of drift phenomena. Okay, and drift phenomena happens to be in the material because of electric field. I hope this makes sense. Okay. So your electron is moving in this direction, so your drift current will move in the direction of electric field, guys. ठीक है, तो आप समझ जाओ. लेट मी हाईलाइट दैट पॉइंट. सो योर drift current is going to be in this direction, okay, and electron is moving in this direction, so your drift current will be in this direction, right? I'm just going to mention that point. So from here to here, your this is, you know, you can say that electron is moving like this, so you can say that B to A, ये direction रहेगा हमारे drift current का, okay, B to A, right? And here your electron is moving like this, so B to C, ठीक है. In the direction of electric field only your current is gonna flow, right? So let me check the option. Drift current is directed from B to A. Is it correct? Yes, B to A. ठीक है. So this option is also correct. Without any confusion, with lot of confidence, right? ठीक है. याद रखना कि let's say the Costco ball is rolling like this, your drift current will be opposite to that. It means that is in the direction of electric field. ठीक है. That is in the direction of electric field. Okay, next. Option A. For X between B and C, the electron diffusion current is directed from C to B. So don't talk about, don't look at the profile between A to B now. Look at the profile between B to C. You know, diffusion current, diffusion, see, this is higher concentration. Now come to this profile, okay, for diffusion process, come to this profile. Forget about this energy band diagram, but you can also talk about energy band diagram. ऐसा नहीं है. See, here the concentration is less, here the concentration is more, right? So, but you know, looking at the concentration profile, you can better talk about what the drift and you know, diffusion process, right? Not in the energy band diagram, because there will be confusion. ठीक है, देखो, क्योंकि slope is like this, you will think that diffusion process will start from top to bottom. नहीं नहीं, ऐसा नहीं है, right? You look at this, this is more clearer picture. So let me again give you kind of technique. Whenever you want to investigate the concentration, I mean diffusion process or diffusion current, look at the concentration, okay, gradient concentration profile. And whenever you want to investigate, okay, or one more technique I'm telling you. Since you want to cancel drift and diffusion current, okay, since you want to cancel drift and diffusion current, so if your drift current is from B to C, you can say, so your diffusion current has to be from C to B. That is for sure, right? So in this question, you see our drift current is from B to C, right? इस direction में B to C है. You can say J drift. Okay, so हमारा जो diffusion current होगा, our diffusion current should be from C to B, and I think option A is also correct. ठीक है, मैं फिर से एक बार बता देता हूँ. Let's say your drift current is in this direction, so your diffusion has to be in this direction. If J drift is in this direction, so your J diffusion has to be in this direction, opposite. Okay, so how many options are correct? 3 options. So your answer is A, B, C. So what is the takeaway from this solution? You have to understand EBD. Okay, EBD कैसे draw करते हैं for non-uniform, okay, non-uniform dot semiconductor. ठीक है. And what is the process called diffusion? Diffusion is a natural process. Diffusion is by, you can say, concentration gradient, okay, and because of this only non-uniform situation. And drift is a process by electric field. See, this electric field can be applied electric field or built-in electric field, okay. I hope this makes sense. So this is a question that I wanted to discuss, and we'll meet in another session, guys, with another update. You guys can follow me on LinkedIn, okay. Just search my name, Dheeraj Misra, and you will find my name, right? And if you have any sort of doubt, you guys can reach out to me, okay, anytime, any work, and I'm always here to simplify your life. Thank you. Keep learning.